Our skaggers all front Donegal, Sligo Leitrim too. We'll get them a slip and then we'll take a sip of the rare old Mountain Dew.
Anyone have any questions before we start? Okay, I'm going to demonstrate some special powers that I have. Name? Ollie. Did I upload the slides for this lecture? Yeah. Afterwards. Are you ready? This is leftover Halloween candy. Any other questions before we start? I'm gonna demonstrate a special power I have. I have some special powers. I have psychic powers. And what I'm going to demonstrate is a collective mind reading exercise. Okay, I'm picking up a signal. I can hear questions, but some of you are afraid to ask. Right? I'm picking it up. So one of the questions I'm picking up is, when is the coursework going to be released? Who was thinking that? Who was wondering that? Yes, psychic exercise. Who else? Yes. Another psychic reading I was getting. I got another psychic reading, but let me think. What was that psychic reading? I think that was the only psychic reading. I think I got a second one, but I've forgotten it already. Yeah, okay. If the second psychic reading comes, I'll let you know what it was, but I forgot it already. And there, by the way, there is a early module feedback questionnaire on Moodle now. It's only available for this week until Monday. So if you have feedback that you'd like to give us about how the module is going, now is your opportunity. It is fully anonymized, so you don't have to worry. Like usually the feedback is something like, this module blows my mind. I can't get enough of it. Can I have part 3? Like, can you give us part 3 of this module? Stuff like that. Okay, so let's talk about object-oriented design in some more depth. Last Friday, we went over objects, some very fundamental questions, objects and responsibilities, right? So there were 2 magic slides from last Friday. One is called Guidelines for Identifying Objects, and then another magic slide was Guidelines for identifying responsibilities. And I can easily imagine looking at those slides and deriving some test questions based on those ideas. Today we're going to talk about collaborations and class relationships. So what is a collaboration? We mentioned collaborations in the last lecture. Now we're going to talk about them in detail. We gave a little overview of the object-oriented design process last Friday, and now we're taking each one of those stages and going into more detail. The first stage, identifying objects. The second stage, identifying responsibilities. And then the third stage being identifying collaborations. So a collaboration represents a request from a client to a server and has the responsibility to perform some objective. It may be able to fulfill the responsibility by itself, or it may need access from other classes. Remember, we introduced this client-server terminology on Friday. So an object can act as a client or a server. If it's making the request, it's a client. If it's fulfilling or receiving a request, it acts as a server. And those roles are always changing dynamically. Right? It can be a client or a server at any time. A server provides services representing its responsibilities. A single collaboration is one way from the client to the server. And you can think of that as a method call, right? A method call is a client-server, initializes a client-server relationship. It's just saying, please carry out this process for me, or please return this information for me. That does not, so a single collaboration is one way from the client to the server. So the object that calls or invokes the method is the client, and the one that receives the method is the server. But that does not mean information only flows in one direction. Can anybody tell me how information flows from a client to a server in this context? Anybody want to answer that question? Who's awake? How does information flow from the client to the server in this context? From one object to a name?
Would it call Sam?
Sam.
Would it be with parameters?
Yes. Method parameters, correct. That's how information flows from the client to the server. You ready, Sam? Did you take out an insurance policy for this class? Oh, close. I feel a little bit too hard. And how does information flow back from the server to the client? Is it Nikki? Oh my gosh. Return parameters, correct. Yes. So on Halloween, I was out too late and I missed everybody that came to the house. So I didn't give away any Halloween candy. Okay, so each collaboration addresses one responsibility in the server. Each collaboration helps to fulfill one responsibility of the client. And this is a visual representation of a collaboration. And the visual representation is a graph. This is called a directed graph, or a directed acyclic graph, a DAG, if anybody's interested. Right, so a collaboration has this arrow. It's an arrow, actually. Here's a class, and it collaborates with class B, and this collaboration is indicated with an arrow, and then it's given a label. The edge is given a label, B1, and same here. So class A collaborates with class C using responsibility C1, and the collaboration is given a label C1. That's how you see a lot of these directed acyclic graphs in like UML, right? In all these diagrams that try to show. This is the challenge with object-oriented design, is trying to understand the flow of information. This is the major challenge, and it is a challenge. It is difficult. And there are tools to help you with that, like the automatic class diagram and collaboration diagram tool. Has anybody ever used an automatically generated collaboration graph tool ever for software? Okay, just curious. There is one called Doxygen. So if you've ever heard of Doxygen, then that will do the trick. So patterns of class collaborations and relationships represent the flow of control and information in the system, and it defines the pattern of communication. What we're trying to understand is how the different components of the software communicate with each other, and how that flow, what the flow of information and control looks like. So how do we find them? Finding collaborations amounts to determining client and server relationships, so we look for dependencies between classes. You can also use your intuition here. For each responsibility of each class, remember, we learned how to identify objects, we learned how to identify responsibilities, and then we learned how to assign those responsibilities to classes. And now we're looking through this list of responsibility that have already been assigned to classes. Is the class capable of fulfilling the responsibility by itself? Right? In that case, there's no collaboration. If not, what does it need? From what classes can it acquire what it needs? So a client is going to need either a process or some data, right? And if that's true, it needs to collaborate with another class. Shared responsibilities also define collaborations. So if we look through the list of classes for each class, what does this class do or know? What do other classes need in terms of actions or information? Right? And this can be also checked with a walkthrough, right? A walkthrough of your software. Okay, so let's talk a little bit about class relationships. So you've all seen, I think, and heard of these relationships before. Finding collaborations can also be facilitated by examining class relationships, like hierarchical relationships, for example, is part of. So there's a relationship called is part of, like a tire is a part of a car, or a finger is a part of a hand, right? That will identify a relationship between two classes or objects. Right, and you can draw a collaboration graph. So this defines a whole part relationship between classes. One class is a composite object, the other is a component. Right, and this is going to be a recurring theme in this module. Right, this is part of, and you can also we're going to have a lecture on design patterns. Right, and there's one very popular design pattern called the factory design pattern that uses this concept. Composite objects usually have the responsibility for maintaining information about its components. And the collaboration might be one way. I'm looking at my fingers. So my hand will know about my fingers. But my fingers don't have to know about my hand. The hand coordinates the fingers, but the fingers don't have to coordinate the hand. Theoretically, I could take off a finger and then give it to someone else, put it on someone else's hand, and then we can swap fingers. You get the idea, right? I think that's really possible, isn't it? I think it is actually possible. I'm not sure, actually. But that's the idea behind the is part of relationship. Has knowledge of, if a class A has knowledge of B, it usually implies a collaboration, right? If they know about each other. Typically, A collaborates with B and asks B for a service, though the server may need to have information from the client also. For example, a date class would have knowledge of the time class, right? Because the date depends on which time zone you're in. Depends upon, similar to the has knowledge relationship, it may be a third class that makes or maintains dependency. And by the way, this relationship is used in the observer design pattern, which we're going to talk about, that kind of. So there's a lot of overlap between these fundamental object-oriented design principles and then using them in design patterns that we're going to talk about. Composite versus container objects. I think you've seen this before, but we're just going to make it really clear now, I hope. Composite objects are object hierarchies. For example, my body is composed of the torso is composed of the arms are composed of the forearms and the hands, and then the hands are composed of the fingers, right? Each of those objects is different, right? My body is composed of different objects. You can think of that also as an object hierarchy. Each component has a different role to play in the composite. The composite is responsible for its parts, right? The body knows how to control the body parts. Parts do not know about the composite, but provide service to it. So my hand provides services, like opening a door, right? But my hand doesn't really have to know about the body too much. And the composite collaborates with its components. So the body is in charge of the individual components. Those are composite objects. Container objects are different. That's where every element is exactly the same. Every object is exactly the same inside of the container, right? And you can think of sets, arrays, and lists. Every element in a set, array, and a list is functionally identical, right? They're all the same. And as far as the container is concerned, they all serve the same role, like an array of fingers, for example. Containers may need to collaborate with their elements, but usually container responsibility is passed along to all the elements, right? To, for example, print yourself, or convert yourself to a string, or draw yourself, right? The responsibility is just passed on to the individual container objects. Does that make sense? Can everybody know the difference between composite and container objects? Hopefully. I think you've all seen that before. Okay, and if we want to document, so how does this come into actual physical being, so to speak? We can document these things. We could document your design. You've all seen one tool so far to document your software design in this module. Does anybody remember what the name of that tool is? I heard something. Who's speaking? What's your name? You were sitting over here last time, right? What's the name of the tool? JavaDocs. That was, JavaDocs is for documenting your source code. But we're talking now about the design. How do you draw your design? Visual paradigm, that's right. Did you say that? Hello? Great. Ready? Oh, sorry. Are you okay? Sorry, my bad. Insurance policy necessary. The first death. Death by Halloween candy. Yeah, so visual paradigm. Visual paradigm is one of the tools that we use to document the design. But this is another tool. It's called a class card. It's a very old-fashioned tool. It's just an index card. And it documents some information like the class name, creation tool, the parent class name tool, subclasses, line creation tool, rectangle creation tool, and then a list of responsibilities and collaborations. These are the responsibilities: accepting appropriate input, determining location, creating a new instance, and then these are the collaborations. These are classes like user input and drawing element. Those are other classes with which this class collaborates with. The creation tool collaborates. So it's just a very, very basic way of documenting and representing classes, responsibilities, and collaborations. The 3 topics we've covered so far in our object-oriented design journey. Does that make sense? By the way, none of this stuff is really that difficult, in my opinion. This is not very difficult. So if you're thinking this is not very difficult, it's true. It's not very difficult, I would say. But to take the theory and put it into practice is not so easy. It starts to become difficult, actually. And very, very few people know how to do this. Very few people. And it's the reason why so many things go wrong with software. Any questions about collaborations? I went a little bit fast because I'm trying to make up for a little bit of lost time. Any questions about collaborations? I will upload the slides afterwards. By the way, does anybody know where you can already see these slides? Do these slides exist in the universe somewhere outside of Moodle, perhaps? That's a fun question. Did anybody know where else these slides exist besides Moodle? Nikki, did you notice?
YouTube, in your videos?
Yes, that's right.
I don't have two.
I have so many. I have like 5,000 pieces. So. Yeah, so if anybody noticed, I have a YouTube playlist with all the lectures on them. And I've given that lecture previously, and it's on there, so you could see the slides there already. And you can see the forthcoming topics as well. Yes. So that's another place to see them. Okay, good. Let's move on to the next topic, which is hierarchies. A very fun topic, by the way. Class hierarchies. There is a quiz, a little pop quiz at the end of this one. So we'll see who manages the pop quiz. So let's talk about software hierarchies. You've all seen software hierarchies already, but we're going to talk about how to formulate class hierarchies. You never went into depth about how to formulate class hierarchies. Like, how do you start from scratch and then build up a hierarchy that makes sense? Right? So we're going to go into depth about how to actually build the hierarchy, what a good-looking hierarchy looks like, and what makes sense. And again, like when you start your first job, you can get a sense, you can see these things in the software that you're given. Your typical first job is to rescue someone else's project. That's your typical first job. It's like a small team, maybe 2 developers, worked very hard to create a new product. They worked on it for a few years, and then they quit the company. And now the company is panicking a little bit, so they're hiring new developers. And your first job also a lot of times involves, oh, can you please fix this broken stuff that these guys left behind? Of course, those aren't the words that they're going to use. But that's actually going to be a very common first job for a lot of you. It's maybe the most common first software development job is, please try to fix and rescue and repair this project that's been abandoned by some other developers that you'll never meet. And you can look at what those developers knew. You can look at their source code and think, okay, did they know what coding conventions were? Like, did they follow any coding conventions? Do they name their objects after nouns? Do they name their methods after verbs? Like, you can see that there's a lot of implicit knowledge and explicit knowledge encoded in the source code. And then you can look at their hierarchies, and you can run some sanity checks on their hierarchies. Do they understand how to formulate good hierarchies? And then you'll know, I'm working on a successful project or a failing project. Like you'll know immediately what kind of project you're working on, if it's failing or successful. So we talked about identifying objects, identifying responsibilities, collaborations. That's our preliminary design. It's a set of classes and set of responsibilities and maybe some collaborations like communication patterns or pairs of classes that belong together. Now we want to go to the next level, which is developing class hierarchies. And this is a backbone to object-oriented methodology. It's like without class hierarchies, object-oriented methodology doesn't have much to offer. I mean, it does, but this is one of the best things about object-oriented programming is class hierarchies. It's one of the biggest advantages to object-oriented programming. It's one of the reasons, for example, that Java was invented. And it's one of the reasons that C++ was invented, right? So in your C class, if you take another C class, you can say, oh, how do I implement a class hierarchy in C? It's not easy. It's very difficult. I don't even know the answer. There's probably an answer, but it's very, very difficult. And that's why C++ was invented. Anyway, this is one of the huge benefits of object-oriented methodology. So we want to also learn about hierarchy graphs, Venn diagrams, and contracts, but we're not going to go into detail on contracts. So this is what a hierarchy graph looks like. You've all seen this, right? This is the tool at the top of the hierarchy, selection tool, creation tool, and then rectangle text line. Again, I'm drawing from the drawing editor example, like the visual paradigm. You could imagine a software design like this for that program. Now, this is not UML notation. This is the notation used in the book that we're drawing on. No pun intended. This little rectangle or square signifies an abstract class or an abstract object. And UML will just notate that explicitly with text if something is abstract. So abstract class, and then these are concrete classes, right? Selection tool and so on. So you've all seen that before. What you might not have seen yet is this notation with the abstract classes. Multiple inheritance, we're not going to talk very much about multiple inheritance because it's not good, but it's worth mentioning. Does anybody know why multiple inheritance is not very good? Is to be avoided, generally speaking? So this array has two parents, this child class, ordered collection and indexable collection. So that's what we're referring to when we say multiple inheritance. String is a child of magnitude and array. Anybody know why we try to avoid multiple inheritance? Name?
You can only extend one.
What did you say your name was?
But you can.
I didn't hear it.
You can.
E2?
So you can't extend to more classes.
I didn't understand.
You can't extend more classes.
The concrete extends more classes? Is that what you said?
You can't extend.
You can't extend more classes. What do you mean? Which class can you not extend?
Like array class, you can't extend two classes.
So array class is extended in this example. It's extended with matrix and string. It is, so the top two, what about the top two?
You want to extend the order collection.
Yep, array extends the top two. Yes, and then there are two more that extend array. So what's the problem?
I don't think we can extend two classes.
You cannot, you can extend two classes using multiple inheritance. That's the whole idea behind multiple inheritance. Anybody? Name?
Daniel.
Daniel, what do you think?
I would just say it can get confusing quickly.
Yes, it can get confusing very quickly. Any other reasons? It does get confusing quickly. Any technical problems with the multiple inheritance? You have a helmet on? Name? Ella. What do you think, Ella?
It's not possible to implement in Java to inherit multiple classes, and then there are all different types.
I couldn't hear you, like my ears are too old.
I don't think it's possible to implement in Java multiple inheritance, and it can't be like multiple types of.
That's right. So strictly speaking, Java does not allow multiple inheritance. But why did the people at Java decide they don't want to support multiple inheritance? Well, there are several reasons, but maybe we can think of one. Hold on. Ready? I forgot your name again.
Shelsky.
Shelsky?
Shelsky, yes.
Shelsky.
Like Shelsky.
Shelsky, yeah. Maybe one day I'll say that.
So if there are two classes above and they have the same function name, then there will be a big problem.
Very good, Shelsky. Did you take this class already? No pun intended.
I watched the video on YouTube.
Okay, you cheated. No, that's not cheating, actually. That's true. So Shelsky said, what if the parents have a methods and those methods have the same name or the same signature? Which one gets called? That's a problem. Major problem. Another problem is the constructors. Which constructor gets called first? So in this case, ordered collection or indexable collection. Nobody knows which one's going to get called first. And a lot of times this is platform dependent. So the behavior turns into something that's platform dependent. In other words, it changes depending on what platform you're using, which operating system, which version of a compiler, which version of a programming language. But yeah, it's a mess. Okay, so Venn diagrams are another tool, drawing tool we can use to represent class hierarchies. We don't generally do this, but it is possible. So in that previous example, selection tool is a child of tool and creation is a child of tool, right? Where was that example? Here. So this class hierarchy is represented here. And then look at this, I think it was Daniel that said that it gets confusing. Look at this one. This one is confusing. Let me see if I can interpret this in plain English. So array is a child of matrix and string. Did I get that right? Oh no, it's a parent of matrix and string. So these are the shared responsibilities of matrix and string. And then ordered collection are the shared responsibilities of array, matrix, and string. So order collection, so array, matrix, and string. So yes, it's very confusing. That's multiple inheritance in a Venn diagram. You're not going to see that very often. Yes. That would make a great test question. No, I won't do that. That would be pretty cool though. I can imagine a test question that says, here's a Venn diagram, draw the inheritance graph. But I wouldn't use a multiple inheritance example. Yeah. So guidelines on building good class hierarchies. Hierarchy in Venn diagrams can help model the is kind of or is type of hierarchy. That is guideline number 1. I'm going to read it twice. Model is kind of hierarchies. Very, very important. Factor common responsibilities as high as possible. So that's the shared behavior. Any methods that can be pushed up to a parent or abstracted up is a win. Because every time you push something up the hierarchy, it becomes more shareable. Right? And you reduce the redundant code. Don't allow abstract classes to inherit from concrete ones. So if there's a concrete class, there should be no abstract class as a child. Period. Abstract classes are always on top, and the concrete classes are always on below. And eliminate non-functional classes. So this is guideline number 1, is kind of hierarchy. Class A is derived from B only if it supports all its responsibility. For example, A is a kind of B. This is something you can look at and know if somebody understands class hierarchies, if they're following the is kind of relationship. And it's absolutely vital because developers get confused. They get confused between the is kind of relationship and the is part of relationship. This is a confusion, very common confusion. So you could say something like, well, what's a good example? A Mercedes is a kind of car. Car is the parent, Mercedes is the child, right? That's the is kind of relationship, and that's the relationship we are modeling with these hierarchies. Very, very important. Here's some confusion. It's not the same as composite hierarchies. So, for example, a lot of developers will make the mistake of modeling composite hierarchies this way. And for example, finger is a kind of hand. No, it's not. Finger is not a kind of hand. That's a composite hierarchy. It's not the same. Does everybody understand what I just mentioned? And I see this mistake all the time. In my last job as a software engineer, I saw the other engineers making this error. And I tried to explain it to them, but they made fun of me for knowing this. But they made this error all the time, and it messes up the software so bad. It just messes it up. So don't mess up the is kind of with the composite hierarchy. Does anybody know the phrase that we use to describe the composite hierarchy? It's not is kind of, it's is something of. Name? Emily?
Because it is part of.
Yes, Emily, yes. You are going to succeed. You are going to succeed. I can see it. Is part of. So don't confuse the is part of with the is kind of. These are the two things that people get confused all the time. Anybody know how? So we're talking about using inheritance to implement the is kind of hierarchy. How would we implement the is part of composite hierarchy. Anybody know how we would implement that? Emily?
It extends.
Not extends, but you still get a piece just for answering. Anyone want to take a guess? It's very, very simple. The answer is ridiculously simple. And it's so simple that people just don't know it even when it's staring them in the face. What's your name? Joe.
So
What would you say?
So it's kind of hierarchy. If we say A is kind of B, then it must have the same height.
That's right, that's right. So in this case, you introduce a new abstract class, or integer. There's already a class called integer for that. Should I just tell what the answer is?
Please.
It's just membership. So one class is a member of another. Like you could have a class called canvas, and it has a member variable called square. Square is a part of canvas. It's just a member variable inside an object. Very, very simple. That's the composite hierarchy. Super, super simple. But people do not think of composite hierarchies when they're looking at their member variables and member objects. But that's how you implement it. Okay, so something I should probably describe this slide. So A is a kind of B, and A is also a kind of C. That's multiple inheritance. We want to avoid that, right? This is what it looks like in the Venn diagram, right? A has all these responsibilities, inherits all these responsibilities, including B's responsibilities and C's responsibilities. In this case, we have two classes, E and F. And this intersection of the two circles represents the shared responsibilities. And what we're pointing out here is that this is not a correct hierarchy, right? If we want to represent these shared responsibilities, we have to create a new class called D, and then E and F inherit from D. There's a mistake in these slides, by the way. This should be an arrow, and then that should be an arrow, not a little square. This should also be an arrow that points up, right? So create a class called D for the shared responsibilities, right? And D, in this case, is an abstract class in this example. Okay, move common responsibilities up the hierarchy. That's the second guideline, right, for creating good hierarchies. The first one being model the is kind of relationship. Very, very important. Factor common responsibilities as high up the hierarchy as possible. If a set of classes support a common responsibility, they inherit it from a common parent. Also, we can introduce as many abstract classes as possible. Everybody remembers what an abstract class is in Java? Anyone remember what an abstract class is called in Java? Name? Yes. Corey. It's not Corey?
Yes.
Corey, I said Corey.
Mark Corey, like Mark at the beginning.
Mug Corey. Oh, okay. I didn't say it's not Corey. Correct.
So there's an abstract class one that you can't create an instance of, but other classes can implement the abstract class.
That's right. And what's that called? I'm not going to throw it because I'm afraid of this versus. What is it called, that class in Java? What is the Java terminology? Anybody? Interface class. Who said that? Correct. Correct. I'm going to get some exercise at the same time. Who would have thought of a good exercise and lecture at the same time? Okay, ready? Who's got that? Everyone have a helmet on? Oh, that was not a bad ago. That wasn't bad. Yes, interfaces in Java. Okay, so this is, if we introduce as many abstract classes as possible, it's likely to maximize code reuse and code sharing, right? And make the system more flexible for future improvements and future enhancements. Often these abstract classes will be the result of some sort of walkthrough where you use your imagination and how could this class be used in the actual software when it comes time to actually deliver it. And also, one responsibility is enough to justify an abstract class. You can think of a responsibility as a method, or a method in the data that operates on that method, right? That's how I think of responsibilities. So one method is enough to justify the existence of one abstract class. And always, basically, you always want 2 or more children in a good class hierarchy. Now, you might have 1 child in a class hierarchy because you've thought, oh, I know that this second child might come in the future. Like, I've done that many times. I'm thinking, oh, I'm going to start the class hierarchy now because I know in the future that there are going to be more children inheriting from this parent. And that's also me thinking about possible future extensions and modifications. Okay, I suggest we take a 10-minute break. What do you guys think? Should we take a 10-minute break? The 10-minute break, if you like, you can use that 10 minutes to fill out the early module feedback thingamajiggy on Moodle. It's near the top of the Moodle page.